Number 15, given the sketch of f prime, sketch a possible graph of f. So this is f prime. I'm going to first of all start by making an f prime chart. If I make an f prime chart, since it's direct f prime to f prime, I'm just going to be looking at whether the derivative is positive or negative or above and below the x-axis. First of all, I'm going to test where it equals 0, which would be here, here, and here. So those critical values will be at -2, at 0, and again at 1. Before -2, my f prime is below the x-axis, so I will put a negative there. Between -2 and 0, my f prime values are positive or above the x-axis. Between 0 and 2, my f prime values are negative or below the x-axis. And after, this should be 2, sorry about that. And then after 2, my derivative values are above the x-axis or positive. Okay, from here we should be able to draw a graph of what f looks like. So we know based on this that I know that my function has to be decreasing and then increasing and then decreasing and then increasing. So if I draw a picture of f, first of all, something has to be happening at -2. It doesn't really matter what's happening. I'm just going to put a point up there. I know that my function has to decrease till I get to -2. So I'm just going to come down till I get to -2. And then I know that I need to increase until I get to x equals 0. So I'm going to increase right there. And then I need to decrease till I get to 2. So decrease till I get to 2. And then after 2, I need to increase once again. So that would be a possible sketch of what f looks like. Problem 16 and 17, we're going to be using this graph given below. And number 16 says on what intervals is, if any, is f increasing. And then 17 is going to be talking about points of inflection. So the way that I'm going to start this problem is by making an f prime chart, and then I'll also make an f double prime chart. So for my f prime chart, just like I did in problem 15, excuse me, we need to see where that derivative equals 0. So the derivative equals 0 here and here. So that is at -2 and 2. Before -2, my derivative is above the x-axis, so those values are positive. Between -2 and 2, my values are below the x-axis, which makes them negative. And then after 2, my values are still below the x-axis, which makes them also negative values. All right, now my f double prime chart. My f double prime chart is, since I'm going from f prime to f double prime, I'm going to the derivative, I'm going to be looking at the slopes. So the slopes are negative all the way till I get to x equals 0. Okay, and then those slopes, and I could also look at that graph as decreasing. The slopes are increasing, the slopes are positive, or the graph is increasing till I get to x equals 2. And then my graph is decreasing, or the slopes are negative, after I get to 2. All right, so I've got that set up. I'm now ready to answer my questions. Okay, f is increasing. I look at my f prime chart, and I notice this is where the graph will be increasing. And I will not start at -infinity. I'll actually start at the beginning of the interval. So I'm going to go from -3 to -2. And the reason for that would be because f prime is positive. All right, and then find the x-coordinate of each point of inflection. Points of inflection have to do with the second derivative, and points of inflection occur wherever f double prime changes sign. So I notice that at 0 and at 2, f double prime changes sign. So I'm going to say there would be points of inflection at x equals 0 and at x equals 2, and that would be because f double prime changes sign.